Okay, so let's get into the day 2 notes of this first unit. Hopefully day 1 wasn't too painful. And day 2, if I'm being honest, some people say it's painful. Some people say it's not. But it's one of the only 2 days we'll have to deal with proofs in this class. What's a proof? A proof is an argument that uses logic, definitions, properties, and previously proven statements to show a conclusion is true. Ooh, that's a lot of technical stuff. The way to think of a proof is to think about a 2 or 3-year-old. What's their favorite question? Why? You need to put on your shoes. Why? Can you come do this? Why? So when you do a proof, think of it like you're telling that 2 or 3-year-old what you're doing. And they're going to turn around and ask you, why? That's the mindset you want to be in. You'll probably also get tired of me saying, why? By the end of this video too. But anyways, if you've ever done an equation in algebra, if you've ever solved an equation in algebra, then you've already done a proof. You just didn't write down your why to each step. You just knew that's what you do. If it's x minus 7 equals 3, then you add 7 to get x by itself. If we had something like this, you just know, well, you add 7. Add 7, that gets you x equals 10. You know that. And so then you say, okay, I'm done. The proof is actually saying why, if this is given to us, why is this step true? So by the end of today, you'll be able to answer that question. So just as a little side note, I'm going to write on here, why is it true? That's what we'll answer. Okay. So now, let's look at this chart. There's a bunch of properties of equalities. So let's just start filling it out, and we'll go from there. This chart will be, I will say, this chart's going to be really important for your assignment. So make sure you fill it out. Okay, so we have the addition property of equality. We can abbreviate that add prop addition property of equality. Because I don't know about you, but I don't want to write that whole thing out. Ain't nobody got time for that. What that says is that if A equals B, where A and B are just variables, then A plus C has to equal B plus C. Kind of goes back to the old saying, what you do to one side, you have to do to the other. And these next three properties after this, they're going to be pretty similar to this one. So for subtraction, we're not going to put that thick of an S. For subtraction, make sure you put a T there. That way I know it's subtraction. If you just put sub, well, look down the list. We have a sub there and a sub there. Which sub are you talking about? So make sure you put that, whoa, where did that go? Hang on, guys, I lost it. There it is. It went haywire on me. Come back, come back. Okay. Make sure you put that T so I know. Okay. Oh, I need to be in the pen now. This is a subtraction property of equality. This one is going to sound pretty much just like the one above. If A equals B, then A minus C equals B minus C. Easy enough. Multiplication property of equality. So mult prop of equality. It again sounds similar. If A equals B, then A C equals B C. And then we have the division property of equality. So if A equals B, anyone want to take a guess what I'm going to say here? Then what? That's right. A divided by C equals B divided by C. Okay, so those are our four basic ones. Add, subtract, multiply, and divide. Now let's get to some others. This one is the reflexive property of equality. So reflexive prop of equality. Okay, this one is pretty simple. If you think of it this way, if you look at yourself in the mirror, what do you see? Your reflection. So that means the things outside of the equal sign have to be the same. So that would be like saying A equals A. It's the same thing on each side of that equal sign. Okay, now we have the symmetric property of equality. Symmetric property of equality. So This one's going to say if A equals B, then, now on the symmetric property, you flip it. B equals A. If A equals B, then B equals A. Next, we have the transitive property of equality. This one's a little bit longer. This one's going to say if x equals y and y equals z, then what do we know about x? X equals z. If x is equal to y and y is equal to z, then x has to be z. Think of it like you're canceling. These middle two are the same. Think of it like these middle two are the same and you're canceling them out. So x equals z. They've got to be the same to cancel, but still, same concept. Okay, now for our other sub. The substitution. So I'm going to call this subs with the S. Prop of equality. This one's probably our longest as far as writing goes. If A equals B, then A can be replaced by B in an equation. So if A is equal to B, then you can substitute A and B for each other in the equation. That's what the substitution property says. And then the last one in the chart is the distributive property of equality. Distributive property of equality. And we already talked about this one yesterday. It's just that A times B plus C, if that was like given to us as a problem, that would be equal to, well, you gotta distribute the A to what's inside. So AB plus AC. Okay, so we got our table filled in. Now we're going to start thinking of making a logical argument. If you start with a true statement, and each logical step is, you can say either valid or true, then your conclusion has to be true. Think of it like you were giving somebody directions on how to get from your house to the school. Come out of my driveway, you turn left, go this far, then you turn right, then you get on the loop, you get the picture. If every step is a valid step to get to the school, then at the end of the deal, you're going to get to the school. But if you told them, you know, a wrong turn somewhere, but then they follow the rest of your directions, even though one step was wrong, let's say they don't know where they're at. They just keep going by what you told them, and you told them a wrong step. Will they make it to the school? No, they'll be lost. So if you start with a true statement, and each step is true, then your conclusion is true. If anything in there is false, the whole thing's false. So an important part of writing a proof is giving the justification, answering that 3-year-old. Why? To show that every step is valid. For each justification, you can use a definition, something called a postulate. We won't worry in this class too much about what that means. A property, we just went over a bunch of those, or a previously proven statement. We don't talk about it here, but in the real world, figuratively speaking, in the real world, you can also use something called a theorem. But we don't mention that here, and that's fine. Don't worry about it. Okay, example number 1. It wants to solve the equation -5 equals 3n plus 1. And we have to write a justification for each step. So we've got to tell the 3-year-old why. Okay, so I'm going to make like a little T-chart here to do our proof. Okay, this is going to be our proof. So we're going to have -5 equals 3n plus 1. How did I know that equation is true? Every step I've got to know that it's true somehow. How did I know that one's true? Because they gave it to us. They gave us an equation. They told us that -5 is equal to 3n plus 1. So if they give you an equation, we say that it's just that. It's given. Now, let's start solving. I'm going to do this in a different color. That way, because when we solve it and we show our work, that's not an official part of the proof. So the next step, of course, would be to subtract 1. But that's not technically a part of the proof. On -5, whoa, I just lost it again. Where did it go? There it is. Come back. Come back to me. Wait a minute, a little bit more. Okay, now we're back. -5 minus 1 is -6 equals 3n. Here comes that 3-year-old. Why? Why is that true? What did we do? We subtracted 1. What property deals with subtraction? Oh, how about the subtraction property? Subtraction property of equality. Fair enough. Okay. Now for the next step, what would we do next? We've got to divide by 3. When we do that, we get -2 equals n. Why? Well, what did we do? We divided. Which one of our properties deals with division? The division property. So this step would be the division property of equality. I don't like how far up he is. Let me adjust him. 1 second. There we go. Much better. Okay, and then do we leave our answer like that? No, we've got to flip it. So which one of these deals with flipping something? The symmetric property. See, it says if A equals B, then B equals A. They flipped it. So that's our answer here. Symmetric property of equality. Okay. So there's our first proof. You just did your first proof where you labeled every step. So now let's move to the next example. What is the temperature in degrees Celsius when it is 86 degrees Fahrenheit? Solve the equation C equals 5/9 times F minus 32 for C and justify each step. Okay. So let's do it. Since we've got to justify, that means we have to do a proof. So let's go and make our table here. Get ready for it, because a proof is coming. Okay. Okay, well, where do I start? Do they give me any equation? something? Yeah, they give me this one right here. C equals 5/9 times F minus 32. So that's what I'm going to write right here. C equals 5/9 times F minus 32. Now, how did I know that equation was true? How on earth did I know that equation is true? Because they gave it to us. So our step here will be given. Now, what other information did they give us? They gave us this 86 degrees Fahrenheit. So this 86 we could plug in for the F. So I'm going to write this equation, C equals 5/9 times 86 minus 32. How do I know that equation's true? We can't say given because that would just be saying F is 86. What did we do? Is there an F in the problem anymore? No. We substituted the 86 for the F. So this is going to be called the substitution property. This is our reason of equality. Now, what could we do next? We could distribute, but there's something easier that I would probably do. Let's do 86 minus 32. Let's calculate this value right here. That'll be C equals 5/9 times, let's see, what is that? 86 minus 32 is 54. Now, this reason for why that's true, we haven't really said anything like this because it's on the same side. We didn't switch anything, we didn't move anything over, we didn't do any of that. But we did make it simpler, didn't we? So since we did it on the same side, we're going to say we simplify. And then last but not least, looks like we've got to multiply 5/9 times 54. So that means C equals 30. Again, did we do anything on the C side? No. We only stayed on the right side. So our reason here would be simplify. And that's it. We solved for C. And we justified our reason. Okay. On to the third example. So for this one, They're actually giving us something that we haven't quite learned yet. We'll get to it. We'll get to it maybe tomorrow or the next day. Or I guess I should say tomorrow or Monday. I can't remember. But nonetheless, by the time you take your test over this, we will have covered it. So they give us this picture here. And what these mean, just so you kind of have an idea of what's going on. This is saying this 5x plus 4 is saying that from k to m, it's 5x minus, not 5x plus 4, 5x minus 4. Same thing with this x plus 3 and 2x minus 1. X plus 3 means that's how far it is from k to L. And then 2x minus 1 is how far it is from L to M. So that covers that whole thing. So our first step here, they want us to solve for x. This Km equals KL plus LM. Right now, just take it for what it is. It's called the segment addition postulate. And this is really important. There's multiple problems on your assignment like this. So I hope you're paying attention. This segment addition postulate. What this is saying, Km, notice that's our, I'm just writing this in green because it's not like official, but Km is our whole line. KL is a part of it. LM is a part. So what the segment addition postulate says is that if you add both parts together, you get the whole thing. Well, what they did here is they gave us that postulate and then they substituted in what each of these are. So from K to M, it's 5x minus 4. That's how they got that. K to L is x plus 3. That's how they got that piece. L to M is 2x minus 1. That's how they got that piece. So they just substituted those in. Now we've got to finish solving. They've got it to a point that we can solve it. So what's the first thing we could do? Well, I probably wouldn't start moving stuff yet. Because if I look over here on the right side, what do I notice? How many x, how many p, let me back up. How many x's do I physically see on the right side? There's an x here, and then 2x there. So how many total x's do I have on the right? One x plus 2x gives you 3x. Now, I notice I have a plus 3 and a minus 1. We got this plus 3 right here, this minus 1. So what's 3 minus 1? Plus 2. Can I do anything like that on the left? No. So I'll just bring it down. Now, using what we've talked about so far, since I only did something to one side, what would our reason be? When that 3-year-old comes up and says, why? What would our reason be? We simplified. We only did something to one side. We made it simpler. So simplify. Okay, now we can start solving. There's multiple ways to solve this, but remember yesterday I said let's move our variables first. So I'm going to move my 3x over. Okay. So 5x minus 3x is 2x. Now I'm going to have minus 4 equals 2. Okay, why is that next step a true step? What did we do? We subtracted 3x. So that's our hint. Subtract. And then we're going to have the property of equality. That's the only subtraction one we know of. Okay, what next? Well, we've got to add 4. So it's going to be 2x equals 2 plus 4 is 6. Here comes that 3-year-old. Why? Well, what did we do? We added 4. So we're going to say the addition property of equality. And last but not least, what do we have to do? Divide by 2. That gets us x equals 6 divided by 2 is 3. And we just can't seem to get rid of that 3-year-old. Why? Well, we use the division property of equality. Okay, so there's that example. We're almost done. I know these are kind of long, but we're almost there. We just have 3 more properties and then a quick example. Okay, so these are the properties of congruence. What does it mean to be congruent, though? Surely you've heard that word before, congruent. Same size as I lose my paper again. Where you at, Willis? Hang on, guys. Come back, come back, come back. Okay, congruence means same size, same shape. That sound familiar? Okay, so we've got three properties. Now, the congruent symbol is this equal sign with a little squiggly above it. It's called a tilde. So an equal sign with a tilde above it. That means congruent. So the reflexive property of congruence, we'll use what we know already about the reflexive property. Means it's the same on both sides, like looking in a mirror. So one example would be like saying the measure of angle 1 is congruent to the measure of angle 1. That's one example. Dealing with angles. Another one would be like segments. Segment AB is congruent to segment AB. Okay. The symmetric property of congruence. This example would be like saying if the measure of angle 1 is congruent to the measure of angle 2, then the measure of angle 2 is congruent to the measure of angle 1. Remember, symmetric is where we flip. And then we can't forget our congruent symbol in there. Okay, last property is transitive property of congruence. So, I don't want green, I want to stay with purple. So if the measure of angle 1 is congruent to the measure of angle 2, and the measure of angle 2 is congruent to the measure of angle 3, then bring out the room there. The measure of angle 1 is congruent to the measure of angle 3. You know what? I'm going to take this then and move it. Because I like to move it, move it. I like to move it, move it. I like to move it. Whoa, not rotate it. I want to move it, move it. There we go. Okay. Last example. They want us to identify the property that justifies each statement. So the first one, the measure of angle 1 equals the measure of angle 1. Which one has it to where they're the same on both sides? The reflexive property, that's good. Reflexive property of not congruence. Not congruence. What's our sign say? Equals. The reflexive property of equality. Here's your sign. Okay, for B, segment XY is congruent to segment VW, so segment VW is congruent to segment XY. What did we do here? Looks like we flipped it. Which one deals with flipping? Symmetric property. So that's what I'm going to say here. The symmetric property of, and then what's our sign? Congruence. So that's the sign I need to put here. Congruence. Next one. Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So angle 1 is congruent to angle 3. It's our long one, the transitive property. But what's it the transitive property of? Here's your sign. Congruence. And last but not least, angle ABC is congruent to angle ABC. Okay, so it's the same. So it's going to be the reflexive property. What's it the reflexive property of? Well, here's your sign. The reflexive property of congruence. Okay, so hopefully this wasn't too painful. That's a wrap for the notes on Unit 1, Day 2. So I'm going to stop the lesson here. Stay tuned for the guided practice.